Welcome, everybody. Good morning and good afternoon to our colleagues in Asia. Yeah, thanks for having us today and having the chance to talk about IDPS. IDPS is a wonderful new acronym for Intrusion Detection Prevention Solution. And we titled today's presentation The Immune System for Connected Vehicle Fleets. So why did we do this? Because we feel that as we are now all aware after the last 1.5 years of our human immune system and how the human immune system is fighting new disease, we could easily compare that to what we do to protect connected fleets from attacks. So this picture will help us today to better understand what is happening in the connected vehicle fleet over lifetime. And so therefore, we try here our best to make the link between these two words. Yeah, and who is we? So actually myself, I'm Jan. I'm lead product manager, IDPS, Intrusion Detection Prevention Solutions. I'm located at Feuerbach, which is part of Stuttgart in Germany. And I'm in the automotive security industry now since roughly 2009, joining Ascript in 2013 in multiple roles in the security consulting world before actually eventually being a product manager for our intrusion detection system and meanwhile the IDPS in a solution picture. Yeah, and then today I'm very much happy that today I have Niklas with me. So Niklas is a trainee in our product management department, and he will support me today, especially with respect to the legal aspects, because we will have a look into what is actually required from a regulatory point of view on a global scale, because it's not only that we have a technical need for IDPS, we do also have a regulatory need. Additionally, we will also hear some information about our VSOC, our Vehicle Security Operations Center, which makes the solution complete, but more to this later. Yeah, maybe, or I hope you know Ascript. So Ascript is basically our home, and Ascript is the cybersecurity leader in automotive industry. We are in the market since 2004, so more than 16 years of experience with 400 colleagues worldwide in basically all major automotive locations. And yeah, we really or we pioneered some of the industry leading cybersecurity solution like our HSM solution, but also our methodologies, especially in the area of threat and risk analysis and security engineering. Yeah, what we have prepared for today basically is first of all, this comparison, which I promised you, the IDPS as the immune system for connected vehicle fleets. So we will start from the human body, and then we will see how this links into the technical field of IDPS. And then we will have a short, let's say, overview on what's happening on the global legal landscape. So why, beside the technical topics, IDPS is so important and a real trend in the automotive industry. Before we then have a short step into the technology side in the car. So in-vehicle IDPS technologies, we will do this only shortly today because we only have like 40 minutes plus Q&A. But I would already like to announce that we will have 3 follow-up webinars where we will go into all the details of the different aspects to give you more insights additionally. Yeah, we will then walk into the backend and cloud side of IDPS technology. So what technologies and what approaches we need to make sense of all the data from the connected vehicle fleet before we for sure have a conclusion outlook. And then we are very, very much looking forward to the question and answer section. So please really feel invited to ask all the things you are interested in the chat box. So let's right away start into the IDPS as the immune system for connected fleets. So first of all, maybe a little bit disappointing, but actually I do have a PhD in technical engineering and computer science, but I don't have a PhD in medical science. So please forgive me today if I do something wrong here with respect to what is happening in the body. For sure, it's simplified. And if one of you is a medical professional, yeah, I think you can even explain this way better. But I think still the simplification and picture here will help us. So what we see in this graph is the immune reaction of the human body in case of a new disease. So in the beginning, so at the 0 day, yeah, we have basically no immune reaction because our body doesn't know about the actual attack or the actual infection in this case. And then we have a recognition phase, and this recognition phase is a very interesting one because there is very specialized cells in the human body presenting the antigens to find such kind of anomalies, I would say, or organisms, to talk more in the human body, which are anomalies, so which should not be there because they could be related to a disease. And the interesting point here is, if we later on look into what's happening in the vehicle, you see that we need exactly such very specialized components also in the car. So this is basically our initial immune system reaction that we learn about what's happening actually in our body with respect to such kind of an upcoming disease. And you could say it's monitoring what is happening there and detection. Then there is a boost mechanism in the body to actually improve the detection and make the result, I would say, more significant. Before then, the actual immune system reaction starts and the body starts to fight against the ongoing disease. Actually, this needs to be balanced because you can also, let's say, overspeed, and then you have a problem because your body gets more ill because there's too much reaction. So balancing the reaction to an infection is an important thing. By the way, that's also interesting if we look into the prevention part of IDPS, that we also need to make sure that we don't do more harm by running the wrong prevention mechanisms or too much prevention actually. And then finally, as the body is almost done with the disease, it's not forgetting. So basically the body is really remembering what happened. So the infection is remembered with the memory cell generation. And that's a very nice mechanism because it helps us to react better and faster the next time we see the very same infection. So we learn actually from what has happened to us. So if we map this, things which are happening in the body, like we have it here on the top, a little bit to the detection and prevention methods in the car, then we see that we can say this recognition phase in the beginning, where the body presents or the cells present the antigens, can be really compared to what is happening actually in a car by monitoring and detecting the ongoing potential attacks in a car in terms of anomalies. For this, you really need specified or very specific components which monitor in the car, which gather all the data you need to take a decision, but then which are also able to locally make a detection, meaning make sense out of that locally. Because if you want to send all the data which you have monitored on all the buses to a backend system or to a cloud system, that's simply technically infeasible. So you need to have logic in the car. This is what we call the IDS sensors in the car. To reduce the amount of data which you want to send to the actual analysis process in the VSOC. But for sure, you get the right data and select the right incidents and the right anomalies. So that's a very important section, and we will have a small look into that today. Yeah, then we have the analysis phase. So this analysis phase is happening based on the data which we get from the vehicles. Actually, what is a little bit different in the automotive industry is that we not only get the data from the car, but we also consume data from other IT systems and cloud systems of the OEM, because the combination will help us to make more sense out of what is happening in the coming from the car. Yeah, and then basically the response is defined. So the response is very specific to the actual attack, and that's also very comparable to what's happening in the human body. Yeah, so the cells presenting the antigens. They are very special for this pathogen, or for this organism having the pathogen. So, and they can only connect to some of them, and then also the antibodies which are activated are really fitting to that scenario, and very similar in the car. There is a response, but the response really very much depends on the actual attack which has happened. Yeah, and finally, the recovering phase. So after everything is well, we do have the immunization, where we're all happy to have this. Meanwhile, maybe also supported by vaccination, for example, for Corona. And in the same way, also for the vehicle, the connected fleets, we have the very same thing. We can have immunization, meaning that the system learned about the attack and can directly activate the countermeasures the next time the attack is there. So therefore, we can really prevent the attack from spreading and having a significant impact. So this is basically what we thought about having the connection between the immune system in the human body and what is happening actually in a connected fleet. Before we will see some requirements from the legal landscape, I would like to introduce you to our classification of IDPS components. So please focus here on the blue text in bold. Basically, if we talk about IDPS, we differentiate network IDS systems, so NIDS, which is systems which which are monitoring the networks around the host where the IDS is running. So let's think about an ECU where we have a network IDS, then this network IDS is monitoring the surrounding networks, which could be Ada CAN, could be Ethernet, potentially also other networks, but to be honest, Ethernet and CAN is so prevalent, and also the attack surface of that is so big that basically the most systems focus really on CAN and Ethernet. In comparison to that, host-based IDS systems try to monitor a particular host. So let's say an ECU, an electronic control unit, running the host-based IDS will try to learn that this actual ECU is under attack. That's very much helpful, especially for ECUs having connectivity or which are quite complex, like microprocessor driven or having POSIX kinds of operating system. And then finally, for sure, in the car, you have multiple of the sensors. So we could talk about a distributed IDS system where multiple of such components are connected to jointly learn what's happening in the car and represent the security status in this one particular car before the aggregated data is basically then sent via a backend link to the so-called Vehicle Security Operations Center. The Vehicle Security Operations Center is an essential component within the overall architecture, because here really all the data from all the vehicles come together so that a joint analysis across the vehicle fleet and then also a joint response can be managed. So we will see more about the details of such solutions then later in the technical part. But before we do that, I would like to hand over to Niklas to give us the chance to learn a little bit of what's ongoing on a global IDPS legal landscape.
Yes, thank you, Jan, and hello also from my side. Let me maybe start with a little disclaimer. In contrast to Jan, I have to admit that I have no PhD at all, but only a master in IT security. So as Jan mentioned, we have no degree in medicine. We have also no degree in law. So please take this in mind for the following part on the legal landscape. Let's first start with a little comparison in our immune system comparison. So to compare to our immune system, similar to the World Health Organization, who gives guidance how to deal with diseases like corona, so for example, wearing a mask or keeping a minimum distance, there are regulations and standards like the ones from the UN that give guidance on the cybersecurity of vehicles. In the next step, countries take these guidances and adopt them into local laws, which are then, in the case of health regulations, made mandatory for the people, and in the case of OEMs, are made mandatory for the OEMs and suppliers. Additionally, many people or OEMs also take the regulations as guidance, even though they were not made mandatory, because they see it as an advantage for them. In recent times, many new regulations appeared that formulate requirements related to IDPS. So in the following, we want to provide a quick look onto them. So one of the most important regulations regarding vehicle cybersecurity worldwide is without doubt the UN R155 for Cybersecurity Management System and R156 for Software Update Management System. The regulations were adopted last summer by the World Forum for Harmonization of Vehicle Regulations, the WP29, and this means that they should be made mandatory for the vehicle type approval in the participating countries, which are colored in green here on the world map. The EU is making these requirements mandatory for the approval of new vehicle types by July 2022 and extended to existing vehicle types by July 2024. And other countries like Japan and Korea have similar timetables, meaning that from mid-2024 on, all OEMs which want to sell products in these markets need to fulfill the regulations. The UN regulations can be divided into 4 distinct disciplines, where the third one in bold here, detecting and responding to security incidents across vehicle fleets, is the one where an IDPS helps in fulfilling its requirements. So let's have a look into the R155. Next slide, please. The requirements are formulated in a quite generic way. And so, for example, they require, or the R155 requires, that the OEM implement measures to detect and monitor attacks. And here in in-vehicle IDS sensor, or our in-vehicle IDS sensors, combined with the backend data aggregated in the VSOC, will help in the prevention of this, or will help in fulfilling this requirement. Then we have the requirement to prevent and respond to attacks. So here, I especially want to highlight the expert knowledge in our VSOC, but in general, also here, the VSOC in general will help to find appropriate responses, and by this prevent and respond to attacks. And then it also requires that the manufacturer implements measures to allow data analysis. And as the VSOC aggregates all the data, this is here the main source that allows an analysis of attempted or successful attacks. Beside of these quite generic requirements, it is also required that mitigations for all threats named in the annex have to be in place, which are much more specific and include, for example, the threat malicious internal CAN messages. So here as a mitigation also in the R155 is named measures to detect malicious internal messages or activity should be considered. What is exactly what a network IDS is doing. Further example are the threats denial of service or unauthorized deletion manipulation of system event logs. Also here in IDPS helps in fulfilling the requirements. So after this look on UNR 155 and R156, covering a large number of countries, let us also have a look on the legislations and standards in China. Next slide, please. So in general, we can divide between legislations and between standards. The legislations are mandatory laws and often refer to standards and thereby make them mandatory. And for the standards, we can divide between GBs, which are mandatory, and GBTs, which are only recommendatory. So there are really many standards and laws related to automotive cybersecurity in general, as we can see in the table in the bottom right of the slide. However, most of them are currently still in the planning phase. Also, many of them contain requirements related to IDPS. So we give an extraction here in the bottom. The mandatory ones on the left side are all quite similar to the R155 and R156. The difference is, however, that they will contain specific technical testing methods. And so for getting type approval, this means that the test results of these test methods will have to be shown to the auditors. Also, the standards contain general, more specific requirements. So we saw before that the requirements from the R155 are quite formulated in generic manner. And for one of them, to also show you this, I want to go into further detail, namely the GBT technical requirements for cybersecurity of vehicle gateway. So as the name says, the scope of the standards are gateways of vehicles. It is currently a recommended standard, but could be made mandatory through regulations, and it is estimated that it will be published end of this year. The concrete IDPS requirements for CAN gateways are the following. So first, it requires a denial of service attack detection. And here, as a test case, it is defined that it must be detected if the bus load is greater than 80%. So we see here really deep technical requirement already specifying a certain amount of bus load. We have the requirement to check signal value in a CAN data frame according to the signal definition and communication metrics, to check the data frame transmission frequency, to check signal value plausibility, and to check for normal UDS channel detection. And on the Ethernet gateway side, a firewall or access control list should be used. Also here, very technical or very specific technical requirements are again formulated, and to have a DOS attack detection and a protocol state detection. So to summarize, we have looked into requirements from the UNR 155 and R156, which will be mandatory in many countries around the world from 2024 on. We then took a look into even more specific Chinese legislation and standards, like the one we see here, from which some are even published already. we saw that IDPS technologies are not only useful to improve the general cybersecurity of vehicle fleets, but will also be required by regulations in the future. So after this quick excursus to legislations or regulations, let us go back to the technical part of this topic, and let me hand you over to Jan again, who will give us more information on the in-vehicle technologies.
Yeah, thank you, Niklas. I think it's good. A lot of us will be technical, people, I would say, me as well. So, and we are often, let's say, thinking about, okay, this is a good technical solution. And actually, that's also right, because I think we are responsible for the security of our cars. So we should build in the best security technology we can think of. But we should also not forget that there's other drivers in the market, and the legislation is definitely right now a very strong driver to really take care of especially also the security monitoring of the connected vehicles. Thanks for summarizing that, Niklas. Yeah, let's have at least an overview on in-vehicle IDPS technologies. We will use our own components here as an example. So all our components start with Cycure. So this is the way you can identify them. And Cycure IDS means it's really an intrusion detection system component. And Cycure Gate, we will see this is a firewall, but let's jump into that. Just to remind ourselves, we are right now, if we take the picture of the human body again, in this recognition phase. So meaning we are looking into the phase where we said in the human body, we have very, very specialized cells to detect that there is actually an organism which might be harmful for our body. And very similar in the in-vehicle portion, we have monitoring and detection components which are very specific to the actual automotive environment. So let's look into that. So this is an overview on typical IDS components which you see in a vehicle. Here we avoid any depiction of an EE architecture, but I think you get the sense that basically we do have IDS sensors, and the IDS sensors are specific for the environment. So typically, for example, for CAN, Cycure IDS CAN is a product which very much looks into the specific properties of CAN communication. So like timing properties, like as mentioned, the DLC check which was also there in China, like the signals in the CAN communication, and the diagnostic especially, because that's a huge area for attacks. And so this is specific to CAN. And on the other hand side, there's also IDS sensors for Ethernet, like our Cycure IDS for Ethernet, looking into the very specific properties of Ethernet communication in a car. That's important in a car, because if you just apply here what you do in classical IT enterprise infrastructure, you will be not successful, because you need to have the properties of the in-car communication, so especially like real-time communication to specific protocols and so on. So you need to have support for that. And even more critical, the whole thing needs to be optimized to run on today's automotive components. So you cannot spend like a 19-inch rack and put it into a car just to have the security. So other IDS sensors, as already mentioned, are the host-based IDS sensors. So the host-based IDS sensors really looking into attacks on the current host, so where the IDS is running. So here's also very different kinds. So a very simple thing could be, for example, in a microcontroller-driven ECU, maybe even running AUTOSAR, that we take the events from the operating system, the security events from an operating system, into our IDS consideration. That's a very minimum host-based IDS. But what we see is, especially if you look into the bigger ECUs, like the microprocessor-driven ones, where you have operating systems which are very, I would say, big, and therefore also have a lot of potential attack paths. That is basically where you have an additional benefit of running a host-based IDS to monitor these ECUs in particular. And then finally, Ethernet firewall. You may ask, okay, why is an Ethernet firewall also an IDS sensor? Because for sure, the Ethernet firewall prevents attacks. But as we have a firewall activation, a firewall policy violation is happening, we want to learn about that as well. So the log entries from an Ethernet firewall are definitely also important. All this data called security events is collected on an actual ECU in a component called the IDS Manager. So the IDS Manager was specified by AUTOSAR last year, and we supported this. So we had been part of the working group, and our version of that is Cycure IDSM. So in this component, we collect the security events on the actual ECU. We pre-process them, we aggregate them, store them, whatever logic is helpful in this ECU before we eventually send them off the ECU as so-called qualified security events to the Cycure IDSR which we see here. And the Secure IDSR is then the component, I call it the IDS reporter, to then send off the data from the vehicle. So at the end of the day, you have a hierarchical structure of IDS sensors, very specific to the automotive environment, absolutely needed to get a good coverage. Yeah, don't stop with the IDSM, really look into the sensors. And then the IDSM to make sense of all the security events in an ECU, and the IDSR finally to make the same on vehicle level. Yeah, if you think about why you may want to go into this adventure, I would say, of introducing IDPS with Ascrypt, here's some arguments. So with all our Secure IDS components, we follow a white box security solution, meaning that basically our systems are rule-based, and we do have a configuration tool to configure our Secure IDS systems, and you will get this configuration tool. And that means you can all the time review what is in the configuration, what is your cybersecurity policy. You can adapt that and change that by yourself, so you're not depending on us as a supplier. You can do this all the time, and that will really help you to maintain the cybersecurity in terms of IDS over lifetime. And there's no voodoo in your car, right? You know what's happening. You are having the control. You are the cybersecurity expert of your car. Second, I already mentioned this Secure IDS configuration tool, and this Secure IDS configuration tool makes use of the work you have already done. DBC files, RXML files can be imported, and then the tool provides semi-automatic rule generation so that a lot of the basic work is already done automatically and will ease your life in the concrete project. We do offer, as we showed you, the complete continuous protection ecosystem. That means we can start from the IDS sensors and we can deliver up to the VSOC, but we are open for any kind of collaboration. So if you have a SOC already and you just want to bring the use cases of vehicle specific stuff to the SOC, we can collaborate. If you want to run all that on your own and you only want to have the in-vehicle components, fine as well. Whatever helps you to get the end-to-end security done, we will support in that. Yeah, I already mentioned that the Secure IDS systems are rule-based. So why have we decided for that? Because it's the most efficient and effective technology for today's EE architectures. We had a deep look into that, and you can really build very efficient and effective solutions which can easily run as a side function in today's ECUs with such kind of a rule-based system versus what you can, for example, achieve with the machine learning. Also, it's deterministic, so that means if you get a report from our IDS systems, you exactly know what happened, and you can directly start to develop the countermeasures without guessing what the system saw. Yeah, and then finally, for sure, we do this for a reason. We do this because we do have the best security experts in our company. We also worked here with our colleagues from Bosch who developed actually the CAN bus. So we do have the domain know-how which you need to build such kind of a system. So happy to explore this adventure with you. Yeah, to conclude this in-vehicle section, I just wanted to show you one picture of zonal EE architectures. Zonal EE architectures, as you may be familiar with, are focusing on having zones, really geographical zones in a car to put ECUs into. So the good thing is that by that you can save a lot of wires and make the car more lightweight, and for sure also save money. The more challenging thing is that those ECUs in one zone will actually share a lot of logic from multiple domains. Yeah, so right now we make a separation by domains typically to build a secure car, and here we will have in this one zone a good mixture of such kind of components, and that will be a challenge for the security. Even more, it's important it's to really have IDS systems in that and distributed IDS systems in that to make sure you still learn an attack which starts, for example, in one zone and it starts to propagate into another zone. So you cannot do this very centralized security policy which you may try to do with today's hierarchical EE architectures. So I will not, let's say, go into the details of all this slide because it's way too much, but important here is the IDSM components marked here as M to collect the data in the ECUs, the IDS reporter component to send the data offline here, as well as the multiple IDS sensors, either in a deeply embedded ECU marked here with the small symbol. Yeah, so this could be like a microcontroller-driven ECU running AUTOSAR, or also here the more complex ones like this one here, where we run then, like for example, in a zone controller, the adaptive AUTOSAR with the corresponding IDS system, and so on. Yeah, so main topic here, IDS systems are helpful for today's EE architectures, but they are absolutely necessary for next generation EE architectures to keep them secure over lifetime. And by that, I would like to hand over to Niklas, telling us what's happening after the data left the car from the Cycure IDSR.
Yes, so let us directly jump into the topic. And again, let's look where we are currently in our immune system comparison. So we have right now monitored and detected our data. So for the immune system system, we had our cells that now show the pathogen to the cells in the body. And for our security, so for our IDPS solution, we have monitored and detected different events. So now the question is, what do we do with the data we collected from the in-vehicle solutions? Or better said, also, what do we do with all the data we collected from the fleet? The answer is to use Vehicle Security Operations Center, or short VSOC. The idea for a VSOC comes from the enterprise IT security, where Security Operations Center are an existing and established solution to deal with security issues. As Jan also mentioned before, in the automotive domain, we have different protocols than in the classical ITs. Moreover, we have different data and the processes also differ. So specific domain know-how is required, and therefore we as provide dedicated Vehicle Security Operations Center, which we can provide with our automotive security know-how as a managed service. The VSOC is basically the thing that completes the picture. It enables the fleet operator to establish a life cycle of permanent monitoring and continuous security adjustments. And it completes the in-vehicle components to an end-to-end solution covering in-vehicle and back-end security. So also when we look to our customers, we see that it's common sense that a VSOC is required to address the regulations I presented in the beginning. The core service we see is incident reporting, meaning that when an incident happens, we provide a detailed summary with actionable response recommendations relying on the data that we have available. So this means in particular, as we can see on the slide, we filter out false positives. We aggregate all the data that belongs to one incident, and we add context and additional information where it is available. So in total, this means that the OEM receives for one incident, one comprehensive report. So starting from left to right, how does our solution look like? On the left, we have our vehicle fleet, which generates a lot of data. Primary, we see, of course, the data from our in-vehicle components, which also, from our point of view, contributes the most value here, as it is a solution that is designed for gathering security relevant data in the vehicle. However, also today, already a lot of further data is collected from the OEMs. So typically starting with diagnostic data, over data on workshop visits, over software status of the devices in the vehicle, and so on. And additionally, we have IT systems controlling vehicle functionality, like, for example, a mobile app that is used to unlock the vehicle and thereby triggers an action in the backend of the OEM. So with this data available, the first piece we provide is to build up a library of VSOC use cases. VSOC use cases means basically to identify data which can be used to detect or to identify which data can be used to detect which threats. The second piece is then the operation of the VSOC as a managed service and provided as a 24/7 monitoring solution for and also with automotive specific threat intelligence to identify the relevant events from a large number of false positives. In the first generation, the implementation of response steps are then seen in the picture on the side of the OEM, for example, issuing a security patch, but this has, of course, to be done on the OEM side. And in the future, there will be also further response possibilities like in-vehicle response components, where we also have currently a research project running on this. If we now look closer into the detailed architecture, so where we see here the platform, process, and people, so this means that we need a platform to bring together the data from the different sources and analyze it. We need processes for the defined processing of events, and we need people, mainly the security analysts, which take care of the events that cannot be handled by the platform alone. Looking into the VSOC architecture here on the slide from top to bottom, the VSOC consists basically of CyQGuard and the SOC part. So CyQGuard is our data onboarding service that collects, normalizes, and contextualizes the data. So to start with, the data from the fleet backend comes in, but it is in multiple different formats. And so we first have to make sure to bring the data into format that can be further processed by the SOC platform. Afterwards, we use additional data from vehicle database to bring contextual information to the events, so that also more information on the according vehicle is made available to, or on the according vehicles is made available to the system. Now we see the CM feeder here, where we send the data for further processing to the SOC platform. The core of the SOC platform is the CM, which stands for Security Information and Event Management. And that is a standard component also in classical IT in which all the data is aggregated. Additional components are bringing more information to the CM, for example, information from threat intelligence sources, and also information that makes it easier for the analyst in the next step to work with this platform, because when an event cannot be handled by the platform alone, so for example, meaning we have an unknown attack pattern, we have our qualified security analysts that take over and that can then evaluate the threat and give response recommendations. This gathered information is then via ticket handed back to the customer, who will implement an appropriate response and immunize the fleet. So to conclude, we saw that the VSOC is the solution that completes the in-vehicle components to form a holistic solution. We saw a basic overview here on the architecture of the VSOC and how our solution from Ascrypt plays together with the OEM side. But for sure, all of this is quite complex and hard to handle in an overview webinar. So for deeper information, watch our VSOC webinar by Jens Gram and Jan on the 26th and 28th of October 2021. So to conclude today's webinar, I want to hand back to Jan again.
Yeah, thanks, Niklas. Let's go to the final slides of today and then start the Q&A session. We're really very much looking forward to your question. Feel free to ask them in the chat. Yeah, what is now finally the IDPS value proposition? So let's start with a problem statement. We do have a changing threat landscape. Yeah. So while we talk today a lot of regulations, we do also have a technical reason to introduce IDPS, because the threat landscape is continuously changing. So we cannot say what will happen to our vehicle in the next 10, 15 years. And our vehicles which we produce today are on the street for, let's say, 10, 15, maybe 20 years. So we need to be able to react on new upcoming threats. So therefore, we need to be able to monitor really what's happening there, and be ready then to respond to that. This is especially true for sure for connected vehicles, but even then for automated vehicles. That's even more important, no? Because if you have an automated vehicle which is connected and that will be steered by an attacker, that really has a very, very high threat potential. Then we looked into mandatory regulations. Regulations are a main driver currently because everybody wants to comply to the regulation to also get the type approval done. So both things are really pushing currently the industry and also ask for high speed of IDPS introduction. So what we can actually offer here as Ascrypt then is really IDPS, intrusion detection and prevention solution, like really end-to-end from the sensor up to the VSOC and back for the prevention part. And this basically consists really of the capabilities to monitor and detect what's ongoing as we compared it with the human body, to analyze and define the response, and then at the end of the day, if the response is rolled out to the vehicles, be again in the position that the car can defend itself, like prevent against any known attacks. And this is a continuous cycle. It's a continuous protection cycle, which will run all the time until the vehicle is not in use anymore. Yeah, as we already mentioned multiple times during today's presentation, it's a huge topic with a lot of elements like the in-vehicle elements, the VSOC, the processes, and so on. So we decided first to generate a white paper for you. The white paper has the very same title as our today's presentation, Immune System for Connected Vehicle Fleets, Intrusion Detection and Prevention Solution. You can find it in the download section of our webpage, and it gives you also another summary of today's presentation and more. Second, we decided to make 3 more webinars. So the next one will be already on the 12th and the 14th of October. While it's fine if you just join once, we do it 2 times so that everybody from the, let's say, international community can join. And so this webinar will have a focus on the distributed IDS. So we will talk about the distributed IDS components in car like Cyclo IDSM, IDSR, and their interaction. And I'm happy to present that together with my colleague Andreas. Then later at the end of October, we will have the already mentioned Vehicle Security Operations Center webinar. And then to conclude and also have an outlook, the webinar number 4 in November will have a look into prevention systems. And here what we mean is having direct reaction in a car. So this is still an area where the solutions are just emerging because you need to be very careful from a safety perspective. But there is already solutions available and more is to come. So therefore we will look into that. And additionally, because it very much fits into the picture, we will also have a deep look into CycloGate, our automotive Ethernet firewall, which is already out there in the world, in the fleets, and which is really, let's say, a good foundation to build secure EE architectures based on Ethernet.